Hello, students. It's December 11th today. The month is flying by quickly. We have an interesting do now today. Today's do now is all about turning your camera on, and we want you today to really have an honest conversation with yourself about why you don't do that and how you could improve yourself if you did do it. Our objective will be to use slope and y-intercept to graph an equation. Our essential questions ask, how can knowing the slope and the y-intercept help me easily graph an equation? And how can I use the slope of a line to ensure that my graphs are exact? After we watch the video, we have 2 pages today on graphing linear equations using slope-intercept form, but in about half of those cases, we'll have to convert from standard form in order to do the graphing. We're going to look at this 4 steps for graphing an equation. Make sure you submit your work, photos of your work at the end of the period for me to look at so I can see your beautiful graphing. This is where now we're at the part of algebra where you students with the art ability really show off their stuff. I've seen some quite colorful work this year. I guess a lot of you like to work with color and art, and that's great. I think algebra looks terrific and these graphs look beautiful in color. You do have a homework tonight where you'll be graphing linear equations in slope-intercept form, and that is 2 pages. To get full credit, we love to see those cameras. We love you to respond when we call, beginning, middle, and end of the period. We need you to submit your completed assignment in Teams, and if you have questions, they are always welcome. I had a couple people write to me yesterday with great questions, and I was happy about that. So let's move on. Make sure you check PowerSchool for missing assignments. And tomorrow, I won't see you because it's Saturday, but it is gingerbread house day tomorrow. Yummy, yummy, yummy. And that's a really cute one. I love that one, although I just noticed it has a plug. I guess it's a light up gingerbread cookie house. Better unplug it before you take a bite. But did you ever do one of those gingerbread house kits? I did a gingerbread train with my grandchildren, and that was so much fun. I used to take couple little kids I knew years ago to the Polar Express train in Essex. We put our pajamas on. Santa would get on the train, give us hot chocolate and cookies, and they would read the Polar Express. And I love all those fun traditions, although this year, as you know, has been very different for everybody. So here is our do now. And we're asking you to take an honest look at the camera usage in class and think, why is it important to turn on your camera during distance learning classes? And when I say important, not just important to you and not just important to teachers, but important to each other. So, when you have your camera on, what message does your presence versus that black screen, sad face, send to your teacher? And think about, what is your reason for not turning on your camera? And is that reason something that helps you learn? And I want you to be honest about that. Students, I know that, you like to kind of hang in bed, and you're teenagers, and teenagers like to sleep all day. But you know what? Even if you're home learning, do yourself a favor and be good to yourself and get up, get dressed, get a shower, get some breakfast, get ready to take on the day just as if you would have done it were you to come into school. This is such a big deal, turning your camera on. So we have our exit ticket that we'll come back to with the steps to graphing a linear equation. So let's get started with our topic, graphing linear equations. Okay, so let's get started. When we graph linear equations, we can use the steps that you see here to graph the equation using the slope-intercept form of the equation. The slope-intercept form is y equals mx plus b. So the first thing you want to do is write the equation in slope-intercept form, the form where y is isolated on the left side of the equation. Then you have the slope, which we represent by m, times the x value plus b, which is the y-intercept. The second thing you want to do is graph the y-intercept, and this is always the point 0b. Here's the b. That is that y point there. But the point on the graph would be 0 and then the b value. The third thing you need to do is use the slope of the line, the m value, to create more points. Now, you're going to create the first point and then you're going to create a second point. And to graph any line, it is a truth that we need 2 points. However, if you want to really double check your work and make sure your graph is correct, you'll do 3 points. I always say do that extra point, and that helps. Now remember, slope is always rise over run, or the relationship between x and y. Then the last thing you're going to do is use a ruler to draw a line that extends through the points, and I want you to place an arrow on both ends to get full credit for all of your work. So the directions ask us to graph each equation using the slope-intercept method. So the first 6 problems, if I look at both of these, step 1 is already done. These are already written in slope-intercept form. So here our m is -1 because we have an invisible 1x, and our our y-intercept is 5. So we'll start with y-intercept, which is 1, 2, 3, 4, 5. And our slope is -1. So down 1 and over 1, down 1 and over 1. You want to graph more than 2 points just to get this perfectly. Okay, so then we're going to put our line and try to make it as careful as we can with an arrow on each end. There it is. Okay, number 2. We are already in slope-intercept form. Our slope is -3, and our y-intercept, or b value, is -1. So let's start by graphing the y-intercept. And we have a slope of -3, so we'll go down 1, 2, 3, a rise of -3 over 1 to the right. And let's do that in the opposite, up 3 and over to the left, okay? And then we'll graph that line. And there's our line. You know, I could have done that a little. Let me erase that and see if I can do a little better job with that line. Yeah, it looks a little better. Okay, number 3, our slope is 2/5, a rise of 2 for a run of 5. Our y-intercept is 2, so we'll graph the y-intercept. Then we have a rise of 2, and this is a positive slope, so a rise of 2 and a run of 5. And let's do -2 over -5 as well, down 2 and over 5. We should be able to get a nice line from that. Okay. So why don't you try 4, 5, and 6 on your own? Okay, so number 4, the slope is negative 1/4. The y-intercept is 3. So we start with the y-intercept, and we're going to go down 1 and over 4. We could go up 1 and to the left 4 as well. So let's graph that line and put arrows at the end. Okay, let's look at number 5. We have a slope of 2 and a y-intercept of 6. So first we plot the y-intercept, and a slope of 2 is the same as 2 over 1, but we can also get a positive slope of 2 with negative 2 divided by negative 1, which is what we'll do here. So we will go down 2 and to the left 1, down 2 to the left 1, down 2 to the left 1, and we'll connect those with a smooth line with arrows at each end. Okay, number 6. The slope is negative 3 over 2, and our y-intercept is negative 5. So first we'll graph the y-intercept, 1, 2, 3, 4, 5. And we have a negative slope here. So we can go up 3 over 2, up 3 over 2, up 3 over 2. Remember, negative 3 over 2 equals 3 over negative 2, which is what I just used here. So let's connect those with a smooth line with arrows. There we go. Let's move on to 7, 8, and 9. And if you want to pause the video and try these on your own, that would be great. Okay, number 7 has a slope of negative 4 and a y-intercept of 0. So the y-intercept is right here at the origin. And a negative 4 slope would be down 4 over 1. Or it could be up 4 and to the left 1. Either way, we'll get that sliding down the sled kind of negative slope. So let's put a line through all these points. And we'll move on to number 8, where our slope is negative 3. Whoops, no, our slope is 5. Almost read that too fast. So this is not exactly in slope-intercept form. Let's do that. It should be y equals 5x minus 3. Okay, I hope you caught that. So our slope is 5, and our y-intercept is negative 3. So we'll plot the y-intercept first, and we have a slope of 1, 2, 3, 4, 5 over 1, 1, 2, 3, 4, 5 over 1. And we'll plot that with a smooth line. And of course, arrows at the end of the line, indicating that that line goes on to positive and negative infinity. Okay, number 9 is similar to 8 in that we do need to do a little bit of rewriting. Y equals 1. We don't want to put the 1. We want to put the minus 6/5 x, and that's a plus 1. So we'll plot, well, our m is negative 6 over 5, and our y-intercept is 1. So we'll plot the y-intercept first. We're going to have a negative slope. We see that from this negative sign. So we can go down 6, 1, 2, 3, 4, 5, 6, and to the right 5. That's only 1. I have to go 4 more. To the right 1, 2, 3, 4, 5. There we go. And we can go up 6, 1, 2, 3, 4, 5, 6, and over 5, which would put us right about here. And let's get our smooth line. With arrows at both ends. You see why they have to be in slope-intercept form? If they're not in slope-intercept form, it would be very difficult to graph them. Now, the problems on the second page, 10 through 17, require us to put these in slope-intercept form. So let's get started with that. We'll subtract x from both sides. Let's change the color. And then we have 3y equals negative x minus 3. We have to divide everything by 3, which leaves us with y equals negative 1/3 x minus 1. So we'll graph, well, our slope is negative 1/3 and our y-intercept is negative 1. So here's the y-intercept, and we have a slope of 1 over 3. 1, 1, 2, 3. And we'll go ahead and graph that line. Make the line a little thicker. Okay, number 11. Got to put that in slope-intercept form. We'll subtract x from both sides. And we have negative y equals negative x minus 5, but we need to divide everything by negative 1 to remove the negative and the invisible 1 in front of the y. So now y equals, now this is negative 1. There's an invisible 1 here. Negative 1 over negative 1 is simply 1. That's an invisible 1. So y equals x plus 5, because negative 5 divided by negative 1 is positive 5. So our slope, our m value is 1, and our y-intercept is 5. Let's plot the y-intercept first, and then we have a slope of 1 over 1. And we'll draw a smooth line. And that's number 11. Number 12. We will first subtract 5x from both sides. Which gives us negative y equals negative 5x minus 3. Now we have to divide everything by negative 1 to get rid of the negative sign in front of the y, which will leave us with y equals 5x plus 3, because negatives divided by negatives are positive. So our slope is 5, and our b value, our y-intercept, is 3, which we'll plot first. And then we have a slope of 5. So we go count up 1, 2, 3, 4, 5, and over 1. But we could also think of it as negative 5 over negative 1. We could go down 5 and left 1. It's a very steep slope in this problem. Okay, number 13. Let's put that in slope-intercept form by subtracting 4x from each side, which will leave us with 3y equals negative 4x plus 21. And we'll divide everything by 3. Which will leave us y equals negative 4/3 x plus 7. So our slope is negative 4/3 and our y-intercept is 7. We'll plot the y-intercept first. And then let's go down 4 and over 3. Down 4 over 3. And we'll plot those points, connect them with a smooth line with arrows at the end. Now let's move on to number 14. Why don't you try the last 4 problems on your own? Pause the video and then come back and check your work. Okay, let's see how you did. First, we'll put number 14 in slope-intercept form. We will subtract 2x from each side of that equation to give us negative 4y equals negative 2x plus 20. Then we'll divide everything by negative 4, which will give us y equals negative 2 divided by negative 4 is positive 1/2 x. Positive 20 divided by negative 4 is negative 5. So our slope is 1 over 2. Our y-intercept is negative 5. So we'll plot that y-intercept, and then we need a slope of positive 1 over 2. So we'll have kind of a shallow, more gradual slope to this. And we'll connect those. And there's the line of y equals 1/2 x minus 5. On number 15, we'll subtract 2x from each side to give us 3y equals negative 2x. And we don't have to write plus 0. It's just y equals negative 2x. Now we divide both sides by 3. And we have y equals negative 2/3 x. So the slope is negative 2/3. The y-intercept is 0. So here's our 0. And we will go down 2 and to the right 3, down 2 to the right 3, or we could go up 3 up 2 and to the right 3. Either way, we've got our negative slope of a line. And number 16, we'll subtract 10 from each side of the equation. So we have negative 8y equals negative 10x plus 24. And we'll divide everything by negative 8. Which will leave us with y equals negative divided by negative is a positive. And so if we've got, I'll write down here, negative 10 over 8, negative 8, that would also equal positive 5 over 4. So y equals 5/4 x minus, the positive divided by negative is a negative, minus 3. 24 divided by 8 is 3. So our slope is 5/4, and our y-intercept is 3. Negative 3, excuse me. So let's plot that negative 3 And our slope is positive. It's a positive 5 with a run of 4. 5, 2, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's enough points for our line. And there's our line. There's our graph. In the last problem for today, we'll subtract 9x from each side, which will leave us with 12y equals negative 9x plus 12. And now we'll divide everything by 12, which leaves us with y equals, we're going to take that negative 9 and reduce it to negative 3 over 4x plus 1. 12 divided by 12 is 1. So the slope is negative 3/4, and the y-intercept is 1. So we'll plot the y-intercept first, and then we'll go down 3 and over 4. Down 3 and over 4. And we could do the opposite, up 3 and to the left 4. And you can see it still maintains the integrity of our line. Let's draw a smooth line with arrows at the end, and that is our last graph of the day. You do have some homework, but let's work on our exit ticket. Write the equation in slope-intercept form, steps to graphing an equation, okay? I'd like you to memorize these. So write the equation in slope-intercept form. Graph the y-intercept. This is always the point 0, comma, and then the b value. Now use the slope. Remember, the slope is rise over run to create more points. 3 is good. Okay, 3 points will generally keep you from having a mistake. Use a straight edge to draw a line through the points and add arrows at both ends. And I have marked them wrong, and other people have as well. If the arrows weren't there, you want to show the arrows. It's very important on these linear equations. Okay, we are really into the heart of algebra now. A lot of you are starting to turn in more work, get your homework done, and do all of your schoolwork. And as you practice, you'll get stronger and better at this. And as you get stronger and better, you'll feel better about yourself. So let's get those cameras on. Let's get the integrity of your education back on track. You're doing this for you, and you will thank yourself for this at the end of the year and beyond. So keep practicing, because you'll be great.